and welcome to today's episode of Rawkode Live. I'm your host, Rawkode. Before we get started, I just want to take 10 seconds to say thank you to my employer, Equinix Metal. Equinix Metal is a bare metal cloud, and they actually encouraged me to keep producing this series and producing quality cloud native content where we can all learn together. So thank you to them. If you want to check out Equinix Metal, please use the code rawcode-live. This will get you $50 in credit, which is roughly around 100 hours of bare metal compute time. All right, today we're going to be taking a look at Rust again. This is part 2. We've been walking through the Rustlings exercises. Today I am joined by Manish Godekar, a Rust core team member and the lead of the Rust Dev Tools. Hey Manish, how are you?
I'm doing great. How are you?
Awesome. Very well, thank you. I'm looking forward to learning more Rust today. So, definitely a good day. Do you want to just give us a little bit of an introduction about yourself? Tell us a little bit more about you.
Sure. I mean, I've been doing Rust since 2013, 2014, before it was stable, when Rust used to break all the time. It was not really a great time, but it was pretty fun to get involved, like back then when there was a lot of chance to make some impact on the language. For the last 4 years, I've been working at Mozilla on the Stylo web browser. Sorry, the Servo web browser. Stylo was a part of that. And actually, starting next week, I'm going to be working at Google on their internationalization team doing Rust internationalization stuff.
Nice. Very cool.
Yeah.
Okay, so I guess I should ask first. I mean, you've been using Rust a long time, so you're probably not that familiar with the Rustlings exercises. Have you done them before?
I have gone through them at some point. I've poked around. I've suggested them to many people, but I've not gone through them like bit by bit myself. I've done like a couple and like read through them, but yeah.
Cool. Well, neither have I, so this should be fun. Right. Let's. We have a hello. Hey, Sangam. Nice to meet you.
Hey.
So, if anyone wants to do this in their own time, these are great exercises. They've been recommended to me many times, so this is why we're doing this today. They're rust-lang/rustlings. We did do a few of them the other day. Oh, Jesus, that was Tuesday. Yeah, there we go. This is Friday. That was Tuesday. The way this works is I run Rustlings watch. It's going to give me a few ticks and say, yep, we did variables, we did functions. Don't know why functions isn't there, but it doesn't matter. It's now telling us that the next exercise we want to attempt is conditionals/if statements. So we'll start there. We may jump around a little bit, and we'll just see what happens. We are using VS Code Live Share today, so Manish and I can both see the same code. You also have the ability to type and fix my very broken code, I'm sure. And we'll see what happens. So if you didn't catch us on Tuesday, the format for these Rustlings seems to be that we get some sort of test. We then have something else that needs completed for those tests to pass. And then when we're happy with that, we have to remove this I am done. Why am I telling you we have to remove the I am done? Because I will probably forget. So, I'll need a little reminder, I'm sure. If we take a look at these tests. Okay, so we have some sort of assertion that 10, and then we get a bigger function which should return. All right, this seems trivial. This is a nice, easy start, right? This just wants me to do an if statement to check for which number is bigger between A and B. Awesome. Okay. I remember correctly from Tuesday's session, the curly brackets are optional in Rust. Is that right?
The parentheses in if and for are optional. The curly brackets are mandatory.
Oh, yeah,
it's the
yeah. Okay.
Opposite of what like JavaScript and C do. This is sometimes confusing.
Okay, so it's right. It's like Golang in this respect,
yes.
isn't it? Okay. Right. So we can say if A is larger than B. Oh, and then I remember this. So
yes, you don't have to write the return if it's at the end.
Yeah, I really like them bindings in VS Code. It's so annoying that every time I get like a complete here, I don't know how to make it go away. Like if I push up and down, and left and right, there we go. See, solving problems. Now, does this code look okay to you?
Looks fine to me.
All right. So A is greater than B, return B. Now, if we can just recap some things for anyone that wasn't paying attention or wasn't even watching on Tuesday, this syntax without a semicolon, can you give me a refresher of what that means?
So basically, in Rust, if you have like a block, and you can do like, I don't know, some work in the block, and the last line, if you say like, I don't know, if I say 5 with a semicolon, this means that the block doesn't evaluate to any value. But if I don't have a semicolon at the end of a block, I can actually do like let x equal to this. And now the value of x is going to be 5 after doing all these things, which means that if you want to return from a function, you can just put like a 5 here, and it's going to return 5 at the when it reaches the end of a function, as long as you omit the semicolon. Similarly, you can nest that. So now what we're doing is, you can see the highlight. Yeah, you can. We are returning this. Since there's no semicolon after the if, this function is returning the value of this if block. And the value of this if block is either A or B, because we have omitted the semicolons at the end of each of these blocks.
Okay. So I'm curious, you've got a lot of experience here. Is this idiomatic Rust, or would you do like an early return here? Like, if you were writing this code for yourself, you're happy with that. This is good, right?
This is idiomatic. Some people prefer doing explicit returns. Like there's some preferences, but typically it is very idiomatic to don't use a semicolon for a return at the end of the block syntax.
Okay.
Like it's very idiomatic to do that, because then you can kind of just look at the end of the function, be like, this is what the function is. If A greater than B, it's A, else it's B. It's easier to read.
Is there a nicer syntax for that? I'm thinking about other languages that have like a ternary operator where I say greater than B. Like, is there a way of doing that in Rust without
we don't have that operator. We use the question mark for something else as well. And we don't have the operator in part because this works, so you can just write that if statement. Python does the same thing. Like, in Python, in Rust, you would just write, if you wanted like a one-line ternary, you just write if A greater than B, A else B, which is kind of weird. But in Python, you'd also do like A if A greater than B, else B, which is similar. But yeah, we don't have a ternary operator, but we do have this, which is close enough in most cases.
Okay, I'll take it. All right, and I'm just making sure the test cases here don't return two numbers the same. That would be mean, but it doesn't look like they do. So yeah. Let's see, did that pass? It did. So we can remove our I am done. And it should move us on to F2. There we go. All right, let's see what we got. We got tests for fizz of foo. Fizz of foo. All right. So first, make it compile. Okay, so the compilation error here, I'm assuming, and in fact, if we use the messages, it expects a string and we have an integer. So naive implementation, I can just do that to fix the first problem, right?
Yep.
But now my tests fail because we're supposed to be running or returning baz or bar. Okay, so get the bar for fuzz and default to baz test passing. So if I pass fizz, I get foo. If I pass fuzz, I get bar. It seems a bit weird, but I'm going to just make that pass then. So fizz is foo and fuzz is bar.
Yep.
Fizz if fuzz bar else as okay. Does this?
There's a small mistake, but
what's my mistake?
You'd need the physics here as well.
Oh yeah. All right. Yeah. Okay.
This isn't like a switch or a match, but we do have that.
Okay, so that passes. So this is now not idiomatic Rust. Is that what you're saying there? This would probably be.
No. I was saying that you've forgotten the physics here, but you added it.
Would you use a match here instead?
Oh, for 3 cases, maybe, maybe not. I would personally use a match. I don't know if that's really more idiomatic. Like for this is fine, I think, idiomatic wise. I would personally use a match, but yeah.
Do you mind showing us the match syntax? That would be cool to see.
Sure. So match syntax would look like oh wait, no, it's backwards. And fuzz. Also, these are strings. And then that's a wildcard. And this should probably work.
All right, let's see. Yeah, okay, cool. So the match syntax, I mean, that looks pretty familiar, like a switch case in other C derivative style languages.
Yep.
I guess it's similar to what I've seen in, at least it follows a similar flow to what I've seen in like Elixir as well. The underscore is familiar there too. Nice. Yeah, that's much cleaner. I'd probably go with that one. Okay, let's remove. I am done. For the people that are watching, if you have questions or any syntax that you want us to try and help you with, if you've been trying to learn Rust on your own, feel free to drop that in the comments, and Manish and I will do our best to try and cover that syntax too. Okay, what do we got next? Primitive types. If I remember, we actually skipped these. They were a bit derivative. So why don't we pick something else then? Let's see. Anything you think would be fun that you would like to do on this list?
I don't know. Like, have you touched any of the moving and borrowing stuff yet?
No, but I would love to move semantics. Will we pop that one open?
Yeah.
All right. Okay. Let's get our test passing then. So Rust watch move semantics 1. Does it move? Oh, I can't spell. Is that the problem?
That.
Yeah, let's try Rustling's run. Okay, that works. Let's do that. Okay. So we have a message here that says we cannot borrow vec1 as mutable. It's not declared as mutable. All right. So that doesn't seem too scary yet. Let's see. Oh yeah, so this push must be the failing. So line 13. Yeah, okay, so that I can fix. I think.
Yep. All it wanted was to be.
That's not what I was expecting from the move semantics first one. Maybe it's just easing us in.
This is easing us in.
Right.
This is very much easing us in. Yeah. In fact, like this is not this is just a mutability thing. This is not a move semantics yet.
Oh, okay. So this one is definitely an error message to do with the move semantics then. Move occurs because vec0 has a type which does not implement the copy trait. Yeah, that seems a bit scarier. So let's see what we're dealing with. So we declare a mutable vector for this function.
Yep.
Okay, I'm assuming the vec.1 push is okay, so the error message is on line. Oh, is that 13 again?
So let's look at the error message closer. Or
yeah,
I mean,
okay.
what we can do is go through the error message, or I can explain what move semantics are first.
Yeah, let's cover that. Yeah, hit me with the basics.
So in Rust, basically, there's some types like numbers which are copyable. So if you have a number and you like assign that number to another variable, it'll just make a copy. So now you have 2 variables with a number in them, and they'll independently change. But some things like, so in Rust, a vector is allocated on the heap. So there's allocation involved, and it can be arbitrarily large. You really don't want to copy that around. What you want to do is, if you assign the vector to a different variable, that variable is now where the vector is. And the way Rust, and to prevent various problems, what Rust does is that it actually stops that vector from being used from the old variable. Rust is very careful about sharing. when things are being shared, it wants that to be explicit. It uses the ampersand to talk about sharing often, and it wants it to be explicit if the shared variable is mutable, immutable, and stuff like that. So what's going on here is that when you so if you look at the fillvec signature, what it does is that it takes it takes the vector by move, like the vector is being moved into the function and then returned, so it's moved out. So vec0 actually vec0 basically left um like is the vector left vec0 here. It is no longer belonging to vec0. It moved into the function and out into vec1. Um, so vec0 is not a valid binding anymore. So we cannot read it over here because it's gone already. It has been moved out. Does that make sense?
It does, yeah, it does make sense.
So basically, in this line, we did a move. Yeah.
Okay, so whenever we pass a variable to another function, that's considered moved. Is that like the borrowing that we always hear about when I read about Rust?
It is the opposite, or it is the counterpart of the borrowing.
Right.
If you
Okay.
you can pass a variable to a function in a way that it gets borrowed, and then that means that the function is temporarily looking at it. But we did not do that yet. We passed it to the function in a way that got moved.
Oh, so if we passed it as a borrow, then we wouldn't have this error as well. Is that another? Okay. Is this line 21? And is that something common in Rust, or is that just to kind of make this code?
It's yeah. So that's actually basically the variable mutability is not that big a deal. Like you can turn it on and off, and that's kind of how you'll turn it on. And that what this is basically doing is saying is creating a new variable that has the same vec of the same name as the old variable, but it's mutable. But there's another way of doing this, and I think it was just done so that they didn't have to introduce the syntax. But you can also just say this, and this would have also worked.
Yeah, I think I've seen that mutability in the function signature before, and I was just curious if maybe this was the more idiomatic way. But you're saying that's actually just to not introduce too many new concepts, probably.
Yeah, it's probably to not introduce too many new concepts. But this is called rebinding, and this is done pretty often. Like in Rust, everything's immutable by default. So sometimes what people do is, if they want something to be mutable, they'll only temporarily make it mutable, and this is how you'll do that. There's a different form of temporary mutability that we can get to later, but this is the variable itself being mutable is something you can turn on and off very easily.
Does that mean that it's also valid to do that?
Yes.
And that makes it immutable again, right?
That would, yeah, because what's happening is that you're just creating a new variable named vec that shadows the old variable named vec, and you're moving it from the old vec into the new vec. The compiler easily sees that these are two separate things, but from your point of view, the old ones be like the moment you name, like you can also do something like let vec equal to 5, and now the vec, there is now a new variable called vec that's whose value is 5, and that vector is kind of gone. You can't access it anymore. So like that's just called shadowing. You can create variables of the same name as old ones, and you can just use them normally.
And does that take up double the amount of space? Can I consider? No, it doesn't. Okay.
Well, if you do let vec equal to vec, no. This compiles down to nothing.
All right.
It should compile down to nothing. Sometimes compilers are weird, but yeah.
Okay, so let's see if we can fix this code then. So what we're saying is we have this empty vector called vec0.
Yeah.
We then pass it into a function, which then means it's now moved. So vec0 is no longer a reference.
Right.
So I guess we have one option. Do we make this a borrow? Or do we clone it? I'm not sure.
I guess one of the issues here is what do we want the actual semantics of this program to be? Because what we do here matters.
So it tells us not to change this line. So from my head, we've got to make sure that vec0 is still binding to the value.
All right. So what we can do here is the easiest way to do this is that we create a copy of vec0. Like so far we've not had this problem because all the things we've been dealing with have been copyable. That if you just say that let mut vec1 equal to fill vec0 and its vec is a number, it'll just copy it. You won't have this problem. And what's happening here is that one way to solve this is just to make a copy. And the way you do that in Rust is called cloning. And cloning is just when you make an explicit deep copy. This, of course, is going to create a new vector. It's going to make a new allocation, do an entire copy of everything in the vector, which is right now nothing. The vector is empty. And then give it to this function. So this function will have a different vector, and vec0 will stay its pristine empty self.
Okay. So, I mean, I do have a couple of like hobby projects that I've been trying my best to write in Rust and then keep getting frustrated. And I do find myself using .clone just all the time as like my escape hatch for things like this. And
that is totally fine. I think once people understand I think as a newcomer, it's a good idea to use clone a lot. And actually, I would recommend that even as an advanced Rust programmer, you should probably be using clone a lot. You probably know enough to be able to write this code to avoid copies, but you really don't need to in many cases. This is often a premature optimization. So if you need to clone, just clone, and like if it becomes a performance issue, you can go back and think of how else could you have done this. Yeah. Like one way to do this without cloning, in this case, by the way, the clone is free because empty vectors aren't actually allocated. But if the vector did have things in it, it would not be free.
Cool. That's good to know. So let's stick with the clone approach then. I'm glad that you've validated that for me. I always felt like I was cheating every time I did it, but now I'm okay.
Yeah.
Let's see. It's happy. Right. Nice. So we've got move semantics 3. Let's see what we're dealing with here. So no test. Make me compile without adding new lines. No lines with multiple semicolons necessary. Right, okay. So we initialize an empty vector. We do the same thing here. And then this one isn't printing vec0, so that should be fine. We then got a push here, but with no assignment. So the problem is here that vec1 is no longer at the same location. Is that right?
Let mut vec1 equal to fill vec0. Print vec1 and vec1.push.
I guess I should read the error message because I'm trying to work out, is this vec.1.push part of the move semantics because it's a function on a struct? No.
Okay. So this is a function that takes a mutable borrow. Actually, I guess VS Code will do this. If you highlight on the push, like if you just put your cursor on the push, it should. Do you see the and mute self?
Yep.
Yeah, that is a mutable borrow, and what that is saying is that for the duration of this function, please give me exclusive access to mutate and read this object. And once I'm done with this function, you can go back to having it. So that's where the borrowing comes in. And that, of course, that's not actually moving it. That's like temporarily doing something. So move semantics, it doesn't break the move semantics.
Okay. Let me get the actual error message then instead of guessing. That would probably be a good start. Okay, so we've got cannot borrow vec as mutable. Oh, okay. So, oh yeah, the problem's here.
Yep.
So the syntax you showed us was we could do that, but we could also have done.
Yeah, but we're not allowed to add lines.
Yeah.
So now we know why it didn't use that syntax in the last case, because it wanted to teach us the syntax here.
Yeah. There was methods there.
Yeah.
Okay, so let's see how far that gets. That's it. All right. Okay. So I'm sitting here looking for some sort of move semantic in this function that doesn't even exist.
No.
Okay.
No, the Rustlings try not to introduce like a billion concepts like one after the other. So it's a very smooth ride.
Nice. Okay, let's read the error message before I open the file then. So move semantics 4 is found macro vec. Okay, yeah. So missing the exclamation mark, right? Let's see.
Is it?
Uh,
Or well, okay.
so
Yeah.
it says use this to invoke the macro.
Yeah.
And okay, refactor this code so that instead of having vec0 and creating the vector in function main, we instead create it within the fill vec. Okay, so
Yep.
does the macro need the parens as well?
Yeah, it needs some form of
Okay.
It needs a parens or doesn't matter.
Oh, really?
Oh yeah, Rust macros. There's some nitpicks here, but like Rust macros, the ones that are like this one, you can do this, you can even do this. It does not matter. Which is why, but people use this because this looks like the array syntax. So if you're making a vector, you'll make it look like an array. Also means that if you want to fix stack array, you can just kind of remove that if you want.
Ah, right. Okay. Well, let's see if that's all at once. No, we got more. Okay. Yeah. So we're still passing in 0, so we can.
Yeah, we don't need to do that anymore.
There we go.
This is also more idiomatic Rust because you typically want if a function's like returning something, you want and the function needs it freshly created. It's better if the function creates it. There's no need to freshly create it and pass it in. We don't do out parameters and stuff like that.
All right. Okay, that's good to know as well. So that's move semantics. That means I know everything I need to know now about that, which I don't think is really true yet. So
there's borrowing, and we touched a little bit on borrowing. I don't actually know if there are tests, if there are rustlings for that, but there probably are somewhere. I suspect rustlings. In my recollection, rustling kind of teaches you borrowing bit by bit, like in pieces, instead of like having a here is a thing where we'll teach you just borrowing. So yeah.
Okay. Well, let's pick something else, and then if we don't find anything else that maybe hints towards what the borrowing stuff is, we can always reopen move semantics 4 later, and then just make that function do a borrow and kind of go through that process.
We don't want it to do a borrow in this case. It's yeah, but we can have examples of borrowing at some point, I think.
All right. Okay. Let's see. Let me just. I'll pick one at random. How about options?
Sure. Yeah.
All right. So we got option 1. Big error message. Okay. So print number function expects an option and it found an integer. Okay. So this kind of looks like generic syntax.
Yes.
Can you kind of just maybe walk me through this for a second? And
Sure. What this is saying is that there is a type option, which has a generic parameter, which means that type can be. It's a type option that you give another type to make the actual final type. So you can have an option of an integer, you can have an option of a string, you can have an option of a vec, you can have an option of any type in this case. And what we're doing here is we have an option of an integer, which in the standard library, the option type is basically either something or nothing, which basically is either you have it's kind of a nullable type. It is either you have an integer or you have what's called none in Rust, or some languages call it null. Rust calls it none. Yeah.
Okay. Kind of reminds me of TypeScript. I'm not sure if you're.
Yeah. Right. So TypeScript also has, I think it's called option, or maybe I forgot.
Yeah, it's the same option syntax, well, very similar at least.
Yeah.
So the error then being is that when we call this print number function, is that we're passing in just an explicit type. So we need to wrap this somehow in
Yeah.
option? So is that just
No,
some?
some. So have you done one of the enums exercises yet?
I haven't done the enums exercises. No. Should we go there?
We could go there. We could go through this first, and like looking at how options use will make you understand enums better. But I think I was just wondering how much I should explain. But yeah, so what option is that the way it actually exists is oops, like that. And what it is that it's either sum and it contains a thing of the type that we passed in. So in this case, because it's U16, what it actually is that this is a U16, something like that. And the none is the null case. So what we're doing is we're wrapping it in sum to create an instance of option of U16 here.
All right, cool. And that's what the unwrap is doing. So we're just saying either give me the none back or the U16.
Oh no,
right?
unwrap is actually if it's none, I unwrap is I don't expect it to be none here. So if it was none, and like basically end the program. It causes a panic.
All right.
So
I mean, I'm going to do that now.
whoops, there we go. Like if we did that, it's going to panic.
All right, let's run it. So option one. Oh, we've
Or
got
I guess we
another.
have to fix other things first.
Okay, yep. So we've got, oh, we expect an option here for the number to add.
Oh, I guess we didn't fix all of the cases.
Oh yeah, numbers is an array of option type size 5, right? That's kind of a syntax then.
Yes.
Which means this needs to be some number
Yes.
to add.
Yep. And
I haven't seen the syntax before, so
yeah, this is the type, by the way. So if you say let x, so the full like let syntax is like let x colon U16 equals 5. And of course you can have a mut here if you want. And this is a type. So using a colon, you can put a type in. And also you can do well, there's actually if you compile, you'll see that there's a compiler error here.
okay, let's do that.
Um,
And not save.
can you go back? Actually, I didn't see what the error was.
Oh, it said that I'm going to run it again just in case I hadn't saved. Yeah, I think that was it. Okay.
Yeah.
But now we have possibly uninitialized numbers.
Yes.
Oh, yeah, that's the error you were going to say there,
Yes.
right?
So what we've done, so in Rust you can do like let x and not say what x is, and then like 10 lines later say x equal to 10. But you have to do it in a way that Rust knows that x cannot be used in this part. X cannot be used in this part, and you have to do it in a way that Rust knows that x is fully initialized at the end. So here, this array, we start off with an uninitialized array, and then we kind of just like fill it with a for loop, and Rust cannot prove that like you're actually creating the full array here. So what you want to do is we can just do like that. Oops, that. And it is this part is actually unnecessary now. So this part is a type annotation, and as you've seen in Rust, let statements usually don't need type annotations. In this case, we're adding one. It was there to help us, I think, and what it's saying is that it's of type option U16. Oh, it's an array, a fixed size array of length 5 of type option U16. But I think this will also work, and this is a way of quickly initializing an empty array, or quickly initializing an array that has the same thing in its value. So you can initialize an array of integers like this. You can initialize an array of strings like this, and they will all have the same value.
Okay. So what, you know, trying to think about, lessons that I take away from this is idiomatic Rust. When you're doing a let statement, do you rely on this syntax, or do you have a preference towards doing something? When do you include them or not?
You include the type when Rust cannot. The idiomatic answer is you include the type when Rust cannot compile without you doing it, which typically occurs in more complicated cases. So this is but yeah.
Yeah.
Rust. Yeah. In this case, Rust knows that this is a str. So Rust, there's no point telling Rust it's a str. The only reason you do this if there's some clarity that's lost for the reader, and that can happen if you have some really complicated type, and you want the reader of the code to know what the type is. But sometimes also you can have some complicated type stuff going on, and you need to tell Rust what the return type there is. And Rust does have some complicated things that so I think a good example of this is now this introduces a lot of syntax at once, but I'm not going to explain everything. I'm just going to say so let's say we have I don't know, that's an array. So what I'm doing is I'm iterating over it, and I'm adding 1 to each element. And then what I'm doing is I'm saying, give me a new vector made out of this. And the thing is that this collect function can return a whole different set of types. You can get a vector out of it, you can get a hash map out of it, you can get a B-tree map out of it, you can get all kinds of things. So here I have to say, doesn't matter really. To tell Rust that when you call collect, I want the vector out of it. And Rust will figure out what you're trying to ask for. And there are some cases where you're forced to do this. And you can also do.
Okay. And I'm assuming that's just because those types implement some sort of collect trait. Is that what makes that work?
It's called from iterator, but yes, exactly. And the collect function is generic over the from iterator type.
Gotcha. I mean, I understand a little bit of that. So, yeah. Okay. So the idiomatic, if the more Rust I write is just don't bother with the type annotations. Let the compiler do it. I mean, the dev tools here are pretty good too, right? If I hover over numbers here.
Yeah.
Well, no, it doesn't seem to know what that is.
Maybe because the code doesn't compile yet. I don't know if it does. It does. Okay. No idea why that doesn't work then.
Oh, it said Rust Analyzer is currently indexing.
Okay. That can happen. So if you run the code with this, you'll see a panic, which is what we're trying to do earlier. Yeah.
Right. Okay. So whenever we use the unwrap function, we have to be pretty confident as the developers that it's never going to have a none value. Okay.
Yes. And yeah.
Okay. Nice. Okay. Let's take a look at options 2. Okay. So expected one off. Okay. I've seen this message before. I don't remember what it meant, but I've seen it before. And then we expected. Okay, so this looks like maybe it's a syntax error.
It's mostly syntax, but there's more as far as I can tell. So let's see which things you catch first. Option 2.
Yep, there we go. I was closing those other windows to see if Rust Analyzer would.
Oh yeah.
Catch up with me again. I don't want to restart VS Code because of our session, so I'll just leave it. Okay. Yeah. Okay, so it's complaining here. Well, there's no if statement.
Well, yeah.
Is that it?
Kind of, but not really.
All right, let's see what new error message.
Yeah, you should look at the error and see what it says. That's still another error. We can fix that one later. We can fix this one first, or I mean, depends on what you want. Yeah, I can do that.
I'll just fix whatever I'll do my best. Oh no, I've angered it. Okay, so cannot find value in scope. Ah, yeah, we don't have a value.
Yeah.
So make this an if let statement whose value is a sum type.
Yes. So have you seen if let before?
Yeah, well, I found it a little bit confusing. So let's just pretend I haven't.
Yeah. So what if let is that so a C when you say let x equal to like 5, what you're saying is that so x is actually a pattern, but I don't think it's a good point to it's not a good idea to explain patterns fully yet, but
Well, that's the same as Elixir. The minute you said that, I thought of Elixir. They must do something similar there. They say assignments aren't assignments; they're actually a pattern match. I don't know if that's the
yeah,
same here.
so this is syntactically valid, though Rust. So this is a range, and you're saying that let the range from 5 to 6 be 5. This makes no sense because if it this doesn't make sense, but this is syntactically valid. What goes in the let is a pattern, and what you're saying, and so you can do like let wildcard equal to 5, and Rust will be like, yes, this 5 is a wildcard, like good, and it will do nothing. Um, so and in patterns you can put variable bindings, which basically say that match it to this and set whatever matched to this variable. This is kind of like regex capture groups, but not really. Um, and so normally this pattern needs to be irrefutable. It needs to be such that in a let statement, it needs to be such that whatever the input here needs to be able to match to this, and that's fine for x because any input will match to x and set to that value. That's fine for wildcard because anything matches to wildcard. That's not fine for let sum x equal to because if this oops. All right, my keyboard shortcuts don't work, so I'm gonna if it were let sum x equal to none, this would not match. And then you've told Rust to say that this is the value of x, but it can't execute this because it won't. But this is where if let comes in place, where you can actually say, so if you say if let sum value equal to optional value, what you're saying is, all right, try to match optional value against the pattern sum of value. If it succeeds, this branch will run, and also this branch will have the value from here. And if not, the else branch. So it's an if with a little inbuilt match.
Okay, that actually helps a lot. Okay, it's like, is that it fixed? I'm assuming we probably want the same
Yes.
here. So if optional value is a none, it's just going to run the second branch, right?
Yeah. Yes. If it's none, and it's not none, but it will run the second branch, and you can try that out if you want. But
it's not quite happy yet. Let's see. Cannot find value, line 22.
oh, because I didn't type let. My bad.
All right. Again, it's saying option cannot be formatted on line 23. So I wouldn't expect that to be an option there. Okay, so there's a vector of optional
Yes.
8-bit integers. So this does the pop first, right? And then does the comparison against the sum value. So the assignment should be the I8.
It's the same thing. Yeah. So it's gonna just
But the option type is still what's being passed to print line.
Wait, what?
It's,
That
it's,
error does not make. Oh, I see. So there's a fun thing here, which is that pop itself returns an option. Because if the vector is empty, what's it going to return? Nothing. So it returns an option of the type. So because we have a vector of options, what pop returns an option of an option. Does that make sense?
Yeah, so we can do the sum value.
Yeah.
Oh, did I not save it? Yeah, there we go. There.
Yeah. And what it wants us to do here is it wants us to. Oh, and it actually says that vector.pop adds another layer of option t, and you can just stack option t's. And what it wants us to do is turn it into a while let. A while let is like, so if let is the sort of pattern matchy version of if. While let is kind of the pattern matchy version of while, which it does this instead of saying if a condition do something, it's as long as the condition is true, do the thing. So it's a while loop, but it's going to match on the value and the result of this statement and give you a value each time. So what this will do is loop the whole thing and return each value until it stops being some value.
Okay. That makes sense. So it's just going to keep popping all those values off.
Yep.
So is that something? Does that mean semantically the actual no, I don't know if you say concrete one, but the patterns on the left and then the concrete value on the right, is that always the case? Can I swap those around?
No, you cannot. They're the patterns. These are syntactically two different things. So like on the left you have a pattern.
Okay.
So you can also put something like and this will cause an infinite loop, but you can put a wildcard pattern there, but you can't put a wildcard pattern on the other side.
Got it. Okay.
Yeah.
Yeah, I think that's how Elixir works too, but I can't really remember off the top of my head. So that passes. Now I'm just going to break it again and do none. And not break it, but that should print the value doesn't contain anything, right?
Yeah. Because it doesn't know the type. And this is where you use the syntax. Well, it needs to be option of U8. This is not going to compile either. Yeah. This is exactly where the syntax comes useful. Not that there's any point to this kind of code really existing, because you're creating a value and then checking what it is immediately. But yeah, it's going to say it doesn't contain anything.
Yeah, I guess the reason for typing this kind of code is educational. It's
exactly
helping me understand it.
But yeah, so in this case, Rust had no idea what the type was, because you gave it none, so it didn't know what was in the option. It knew it was an option, but it didn't know what went in it, so it didn't have a complete type. And it didn't need to, because it would never hit the branch that needed to, but it wants to know all the types completely. So you have to tell it what the type is.
Okay, one more thing before we move on then. Just because what you're talking about there is the compiler trying to infer the thing. Can I remove the option here because it knows the X isn't in? Oh, because there's no none value, right?
So you can't remove it. You can replace it with a wildcard. So types can have wildcards too. I suspect this, and actually in that case, because you used vec new here, so Rust already knows that this is a vec of something. It doesn't know what that something is. I suspect it won't compile. There's no reason why Rust won't. Like, Rust could make this compile at some point. My suspicion is that right now this won't compile. And this is basically that. Or, okay, it does. So it's smart enough to be like, it's a vec, and it's like, I'll calm down. I won't I know you haven't told me what the whole vec is, but I'll wait a little bit and see if you can tell me eventually. And so it's like, right now, all I know is that it's a vec of something. And, oh, okay, you pushed something to it. Now I know what it is. But there will be some cases that are similar to this where it won't. So, yeah, what I always do is just, like, write it without the types. And then if it complains about types that I know what they are, I just add them in.
All right. Clever compiler.
Yeah.
Okay, so that was options. You want to jump over to enums then?
Sure. Yeah.
All right. Let's run the test. Enums 1. Okay, what have I got here? So no variant or associated item named quit found for enum message line 12.
There's a nice big fat to-do saying, well, oops.
Yeah. So this is just an empty enum, right? It's
Yeah.
actually got no definitions, types.
Nope.
Okay. I mean,
Yeah.
I'm assuming this is going to work.
That is going to work. Yeah.
Are the commas optional, mandatory?
Mandatory.
Mandatory. Okay.
Yeah. Commas are optional in a few cases, but not for enums. The last one is optional, but yeah.
Yeah, I think if they're mandatory anywhere, I'll probably just put it on the last one too. All right, that worked. So this syntax is that how we always? Let's see if I can get autocomplete. Yeah, okay. That's just how we reference members of an enum.
Yes. Yeah. Basically, so have you seen like paths and modules yet? Like, have you seen the use statement?
Yes, I have.
So like this is just a variant of that. And what's going on here is that the enum message kind of has children, and they're scoped under message. So you can also do like if you did use message quit, then you could just say quit. You could just say quit. And that's what happens with option, by the way, because if you notice, we didn't have to do option some and option none, and that's because by default Rust directly imports none and some.
All right, cool.
Yeah.
I've used the syntax and never really known what it does. Can you maybe explain that to me too?
Oh, sure. So the print, this is the print format string. The format string syntax in Rust is pretty robust, and oh well, that didn't autocomplete. So like when you don't when you use this, it means that this is this parameter, and you can also like number parameters. You can even name them like and you can say equal to 5. You can do all kinds of stuff here, but when you're just using braces with no question mark, this means use what's called the display implementation. So there's a trait called display, and it's implemented for types that have that are intended to be displayed to the end user, and the implementation tells you how you do that display. This thing means debug, and what it means is that this output might be ugly, and you probably don't want to actually display it to the user. In this case, actually, what the user would see is just the words quit, echo, move, or change color, because so this derive is automatically deriving an implementation. But for example, if you did if you did derive on debug and then struct foo, the debug implementation would print something like which you probably don't want to show users. Yeah, so display is, and typically display is something that is written manually. You will look at your type and you will decide how best to display it to the user, and you'll write a manual implementation. Whereas debug is almost always custom derived that way. So this is basically, while debugging, if you use the :?? syntax, you can just, this is how you'll see your own types, and it will show you basically everything that's in them.
Okay, so I just want to confirm I understood that correctly. If I remove the derived debug in this, will this fail to compile?
Nope.
Okay.
Yeah.
Cool.
Yeah.
That makes a lot of sense. All you need is someone just to explain it, and like boom, like cool.
Yeah.
All right.
So it's very normal to just slap derived debug on basically everything you write in every structed enum in your program, because at some point or the other you're going to print it out for debugging.
Cool. Good to know. All right, let's pop open enums 2. Let's see. So we don't have any variants for our message one, but I can see here we do. Oh, these ones are getting fancy. Okay. So we got a plain move and a plain quit.
We don't have a plain move, but we'll get to
Oh
that.
no. Oh yeah.
Let's do the other two because you've seen the syntax there before.
Okay, so we got. Let me start from this. So we got
Yeah.
change color. All right. So change color is a tuple. All right. So that means I did that.
Yep.
U two. Echo. Tuple of string.
Yep.
So, yeah. Is it still a tuple if it's one? I guess so. Maybe I'm thinking.
It's just most enum variants look like this, so we don't actually. They're technically called tuple variants, but we just call them variants, or dataful variants, because almost always they look like this. Almost always they use the parentheses and not the braces. The braces are actually pretty rare. And you use them when, like over here, it's pretty obvious that this is red, green, and blue. But if you had like a bunch of U32s and they all were different things that like were different concepts, it is often better to just name them. And that's where the thing used for move comes in, where you actually have to give them a name. And that you just do, but like it uses the struct syntax, like that.
Nice. So enums can really be a pretty flexible component then. Like,
Yes.
I mean, one of the things I'm thinking of in my head as soon as I've seen this is like, if I want to write endpoints that take gRPC messages, like that could just be an enum of all the different messages I can receive on an endpoint, and I could match and work on that or something.
Exactly. Yes, and match is how you usually deal with enums. Like, I mean, I showed the match with just values earlier, and I'm sure that probably the next exercise will have this, but I showed the match with values earlier, but the match statement takes patterns, so you can do things like match message and say move X, Y, something, quit something, echo something.
Ah, cool. I like it. All right, let's see if we fix this then. Enums 2, and we did. Okay. What's this call function?
So
oh no, that's just okay.
And all it does is it uses a debug implementation. And I guess if you run it, you'll realize that the debug implementation of this enum is not very pretty. It's not something you'll want to show to the user.
This one?
Yeah, this is not something like if you had a end user, not a programmer using your application, you probably wouldn't want to show them change color 200, 255, 255. You'd want to show them like change the color to this color or something. So
yeah, okay.
Also, this is probably an internal message, so you'd never show it to the user in the first place. But yeah.
Well, you'd hope so, but know, I'm a bit of a cowboy at this stuff, so I'm just going to make them smaller and make this bigger. Is that going to? Does the compiler know?
The compiler does know.
I'm your compiler. Cool. Is there? I mean, U32 is not exactly massive, right? I mean, is there only special circumstances you would use anything smaller? Like, is there any rules around that?
There's nothing smaller than U8. I mean, in this case, if you're talking about 256-bit color, you probably want to use a U8 so people don't give you a number that's too big. Yeah, like that's basically when you start using U8s, and often you actually want to size optimize. Often, like, I mean, I've worked on browsers and stuff, and in browsers you often have these structs that are just everywhere. Like, for example, the node type in JavaScript, like for elements, everything is a node, and you need to allocate that again and again. So if you can just shave off, like, if you can pack a bunch of things that don't need to be 32-bit integers into 8-bit integers, then you can just have more of them, and you don't end up allocating so much because you're allocating them thousands and thousands of times.
Cool. That's good to know. All right, let's see what this last one is, and then we'll decide what we want to finish on. So, in a message, a struct point. Oh yeah, I'm going to need another message here. So let's see.
Oh, I see.
So variant or associated item change color is not found here, and this is on line 54.
Yeah.
So this is doing state process. Oh, so I'm assuming this process maybe does a match.
Yes, except we have to write it.
Ah, there we go. This will create a match expression to process the different message variants. Sorry. See, message. What does it pass in? Just a straight up type. So that's just going to be like this, right?
Yeah. Well, not quite, but we should first define the enum, because that's also not done.
Oh,
Yeah.
okay. All right, what do we got then? Let's just copy these.
You also won't want the message : : Yeah.
Yeah. So we've got our quit message, we've got our change color, which actually needs to be.
So there's a subtle difference between this one and the last one, and if you compile it, you might notice.
Was that the double bracket? So it's actually expecting a tuple of.
Yeah, it's what it's decided. What they've decided is that the color type that they're using is a tuple itself. Yeah.
Okay. This one just has to be string, and this one just needs to know. Oh, well, this is a type, right? So can I just do
Yep.
that?
This is just like the string one. So now they've made it a little bit clearer, cleaner, and so now there's just a point type.
So the Rust compiler doesn't care that this struct is defined after the enum, that none of the ordering matters. Okay, cool.
Within the same crate, everything can find everything. I mean, if you create something recursive that it doesn't like, it might cause a problem, but you can have self-referential stuff as well.
Okay, state looks fine. So now we're back to this match statement then.
Yeah.
So we're matching on message, and we want to. What was easy? Quit was just empty, wasn't it?
Yeah. Yep. So, well, we can just do an empty for now.
Yeah, I thought maybe if I could just get it to compile.
Yeah, that's a good point. The test failed, so it compiled.
That's good.
Yeah.
So what's it actually expecting? It wants me to set the properties on the state to be the values, right?
Yeah, but the state function already has methods that do this, so I think we just need to call them.
Oh, okay. So for quit, we're just calling quit.
Self.quit, but yeah.
And then we want to handle message, change color, message, right?
Nope. Remember what we did in the iflet to get access to the thing inside the enum?
Oh, yeah. So we need to do that?
Yep.
Okay.
Yeah. Also, just to note, because so remember when the color was not a tuple, if it was like this, you'd do something like this. If that makes sense.
Oh, yeah. Okay, yeah. Oh, because it's tuple, it's encapsulated as a
because
single.
it's tuple, this is just a single thing. Yep.
Okay. And we've got one more, don't we? So
Echo.
Echo. That also takes a param. So see.
Neat.
Cool. And I'm assuming removing this, the compiler is going to complain that we don't handle all the cases.
Exactly. Yeah.
We could just do that, but then the test will fail. So.
No, the test will actually pass. because the echo thing doesn't do anything that can be tested.
All right, we'll leave it like that. All right, let's pick one more. Anything you think would be fun to do? I mean,
what would you like to do?
okay, so there's a couple of things. I think let's pick the one that you're most interested in. Now, I think maybe doing something around testing would be cool. Clippy's jumping out at me because I don't know what Clippy is. Yeah, maybe one of those two.
So Clippy is Rust's linting tool. And the Rust compiler tells you when your code's wrong. Clippy tells you when your code's bad, or not perfect.
Okay.
Yeah.
All right.
Yeah.
Well, I guess we could take a really quick look at Clippy, and then
Yeah.
maybe we'll take a quick look at tests, and that should take us up to our time. So,
yeah.
So Clippy is a tool, is a collection of lints to analyze your code. Okay, let's run Clippy one and see. Is it? I still just run Rustlinks, don't I?
I'm not actually sure how they do the thing, but okay, yeah. They've set it up so that it fails to compile when Clippy has an issue. So Clippy warnings show up as Rust warnings when you use Clippy, so they look the same.
Okay, and we've got a whole bunch. Okay, so this is like one of these lint rules is on by default, which means that it's telling us our code could be better.
Yeah.
And this is telling us that we're comparing a 32-bit float with a 64-bit float, which is maybe bad.
Oh no, we're just comparing floats. We're comparing floats for equality. And the problem with comparing floats for equality is, for example, things like 3 divided by 2 point is not actually 1.5 because floats are weird.
Yeah, this is the weird precision thing. I think every language has that, right?
Everything, yeah, everything with IEEE floats has that. So the idiomatic way of doing float comparison, where you're comparing for equality, like x greater than y is fine, but x equal to y or not equal to y, is you need, what you do is you compare them up to like a small delta, like a small error value. And what people often do is, so if you look at the error message, it actually tells you what to do.
Use absolute. I'll just copy this. So if
and we need to pick an error value. So you could just put 0.001 there. It's a pretty big number, but you yeah.
So what did you tell me to put there? 0.0.
Some small number, probably smaller than that actually, like just a bunch of zeros. The Clippy actually tells you something else. Yeah, you're using like a very small error value. You're saying that I consider these to be equal if they're closer than that number.
Yeah, I understand now. Yeah, so we're doing y minus x absolute, and then checking to see if the differential is bigger than the small number that we're willing to accept as an error margin.
Yes.
Okay.
Yeah.
Cool. And the message probably would have told me that.
The message said there's an F32 epsilon. So the Rust standard library has like you can also, what you can put here, and I think you might have to import it, but if you do this, or F64, because we're using F64s. If you do this, it will, that is the value the Rust standard library recommends.
Yeah, that worked. Compiled and passed. All right. And the epsilon is just Rust standard library accepted marginal value, I guess.
Yeah, actually.
Does it define it if I hover? Oh, no, because my analyzer's acting up. Okay.
This is the difference between 1 and the next largest representable number. So this is actually kind of like the smallest difference. Often you will want something like bigger. Like epsilon is very small, so it depends on what you want. Like if you really care about that much precision and your numbers are that precise, you would use epsilon. But in this case, maybe not. Like in this case, you just figure out where you want things to be the same.
All right, sweet. All right, what does Clippy 2 tell me then? Let's just run it.
Also, if you're like on your own projects to run Clippy, you just run cargo Clippy.
Oh yeah, I don't know how this project is set up, so I don't want to run that against everything here. But
No, this project is set up differently.
So this is complaining because it says for loop over an option, which is an option. This is more readable. Okay, so this is telling me that my code is just more readable if I change it to an
Yes.
lit.
Yeah, like I said, it doesn't tell you your code is wrong. It tells you your code is bad.
All right, I'll get used to its warnings then, I guess.
Yeah. And you can also not. It's not that big a deal to not use Clippy. Some people, it often teaches you things, so people like to use it as a learning tool. But so what it's saying here is that, so you know how you can do like for x in vector. So vector is an iterable, which means you can give it to a for loop or iterator functions. So it turns out option is also an iterable, and it's an iterable that either if it's sum, it gives you that one value. If it's none, it gives you nothing. Just like a vector is an iterable that gives you all the values it has. So sometimes this sometimes causes confusion. You rarely want to say iterate over everything in this option because that's just an if let. So what Clippy is telling you to do is just use an if let here. Because this is confusing because people don't usually remember that an option is an iterable. It's like there are good reasons for option to be an iterable, but it also leads to sharp edges like this where you have a for loop and you're like, oh, this is looping over many objects, and it turns out it's only looping over the option, so it's only looping over one.
Yeah, that makes sense. Okay, and if okay, that makes sense. Let's yeah, we don't need to save that one. Let's go for traits tests. So I mean, we've already kind of seen this syntax a few times now because some of the rustling exercises actually ship with a test. So are assertions always macros?
Yeah. Assertions are macros because they're macros because they actually kind of like if you say assert like 1 equal to 2, it will actually print this part out along with the assertion. And I think you can even use format string syntax if it fails. Like, actually, I'm not sure. I don't think you can, but it will actually print this out. So they're macros so that can look good.
Okay.
Otherwise, you'll just get assertion failed and then like a string if you added one. But if you over here.
I'm just asserting that the statement evaluates to true inside the brackets. That's it. Okay. Run tests. Run.
Yeah. And if it won 1 equal to 2, you'll see that it'll say assertion failed 1 equal to 2. So it needs to be a macro so it can actually say that 1 equal to 2, because if it was just a function, the function has no idea what expression you put in its parameters. It only knows the value of that expression. So that's why it's a macro.
All right, cool. And what is this CFG test?
So in Rust, basically this is saying only do this in test mode, only compile this module in test mode. So right now it doesn't really matter if you just took this function and put it outside, it wouldn't matter. But often sometimes you'll have like imports and stuff that you're using in your tests. So it is standard practice to put all of your unit tests in like modules that are called test or tests, and you put a CFG test on it so the normal compiles don't even see that code. And when it's in test mode, the compiler's invoked with CFG test on, and then suddenly this module is enabled, and then it finds the tests. It prevents like if you're writing a library, because again, like these are you use this is how you'd write a unit test typically. And if your library has lots of unit tests, you don't want downstream crates to care about them, and you don't want like your imports to be mixed in with the other imports. For example, in your test, you might be importing some test dependencies, and you want to be able to import them without the rest of the code having to also import it. So you'd use CFG and you'd use some cargo feature stuff and you use a bunch of things, but yeah.
Okay. And this just tells it that it's a test that should be run to evaluate the asserts and not. Does that mean I can have functions inside of this module block that don't get run as tests?
Yep. Only things that are pound test are evaluated as tests.
Okay, and you said that unit tests should be in this format. So like integration, acceptance test, they all live in a test folder then, I guess.
Yes, there's a test folder, and you still write tests with pound test, but you won't use CFG test because that folder will always be invoked with CFG test.
Right, got it. Cool. All right, let's pop open one more. So are these just introducing new macros? Okay,
Yeah,
that one's a
there's
bit different. Okay. So this is an assert equals. I mean, I feel like we just did an assert equals, right? Oh, is this because, oh, right. Okay, that's going to accept this syntax, right?
Yep. And we actually want to fix this so that assert can just do this. But the reason it's a separate macro is so that if it's not equal, it can actually just tell you these are the two values. Instead of just saying assertion failed, it'll say assertion failed because 1 is not equal to 2.
Okay, I guess that's not really a problem for simple cases where it's just two numbers, but for maybe if you're comparing two objects to struct, something like that, it may be more important for those
Yes, for
to
two
be printed separately.
It actually often matters for numbers. Like you might do assert equal vec.len and 0 to make sure that it's 0. You can also assert that it's empty. But if it's not 0, you might want to know, like, does it have one thing? Does it have 500? So like you often do it that even like I've used this for integers.
Okay. I'm assuming there's other. Yeah, there we go. There's a not equals. So.
Yep. Also, there's like I think assert approx and there's a bunch.
Those two are listed just now, so I'll stick with them. Let's run test 2. It's happy. Just why not?
Yeah.
Oh, yeah, because they're two different parameters, it can actually separate them in this view.
Yes.
Okay. All right, let's see what this last one is, and then we can finish up there. So we have a function doing modulus even, returns a bool, and we have to just write the test to make sure the function works. Okay. So if I call is even before, we would expect that to be true.
Yep. You don't actually have to have the equal to true.
Ah, right. Okay. Yeah, of course.
Yeah.
Because the statement within the macro has to evaluate. Okay.
Well, you'd have to.
But this one does, right? Or
you can just put a not there. Some people actually do prefer the equal to false over the not, just because it's easy to forget the not. It's easy to miss it while reading, but yeah.
Yeah. I've always been taught to try and I had this drummed into me from very early days. They always put the static value on the left, so it's easier to read. I don't know if that's true, but
yeah, those are called Yoda conditions.
Yoda conditions, yeah.
Yeah.
I've just always had that ingrained with me, and it's kind of stuck. So I'll just copy that too. All right. We've got one more test to do. So, I already did that. Oh.
Well. No, wait.
Is false when odd. Left is 1, right is 2.
Oh, it's failing on test 2. It's failing on the other test. You're running the wrong test.
Oh.
Sorry, you're running the wrong file.
Yeah.
Yeah, each file has multiple tests.
That's
confusing.
Yeah, but I don't like when I look at trivial code and I can't work out what's going on. So that's good. All right, awesome. Thank you for that. That was really good fun. So that was we got through quite a lot there. I think that was a really good exploration of pretty much everything that was left in these exercises. There's only a few things there. So I just want to say thank you for taking the time out of your day. I know you must have a lot on your plate. You're starting a new role next week, so thank you for making the time here and kind of guiding me through this and sharing your knowledge. It was really, really, really good. I enjoyed it.
Yeah, you're welcome. This was really fun.
Thank you. Well, you have a great rest of your day. Enjoy your weekend. Good luck with your new job at Google next week, and thank you again.
Yeah, thank you for having me. This is great.
Cheers.